Hello all, I am Pooja. Welcome back to Periodic Chemistry. Let's learn how thermodynamics and electrochemistry are interrelated to each other. We know thermodynamics is a branch of physical chemistry which deals with relationship between heat and other forms of energy like mechanical energy, electric energy and chemical energy. So here we will learn the relationship of heat with electric energy or chemical energy. So let's start. Let's quickly go through the formulas that will be needed to solve the numericals. First formula is for electric work, which is equal to charge into cell potential, which is equal to NF into E cell. E cell is the cell potential and F is Faraday, that is 96500 coulomb per mole of electrons. That means charge on 1 mole of electrons is 96500 coulombs, and therefore charge on n number of mole of electrons will be equal to N into F. Another formula of electric work is electric work equal to minus delta G. G here is a thermodynamic term which is equal to Gibbs free energy. This is a very important term which determines the spontaneity of the reaction. We have seen and studied about spontaneous reactions in my previous video. Now we can see that in first two equations, electric work, that is the left hand side, is equal, and therefore we can write delta G is equal to minus NF E cell. Also, when we take this term in a standard states, that is when concentration is 1 molar, pressure is 1 atmosphere and temperature is 25 degrees Celsius, that time we can write this equation as delta G naught equal to minus NF E naught cell, where E naught cell is a standard cell potential and delta G naught is a standard Gibbs free energy. Another formula or equation in this topic is delta G naught equal to minus RT ln K. This gives a relationship between Gibbs free energy and the equilibrium constant. We will not go more into detail about the derivations because it is already given in the textbook. Our main focus will be on using these formulas to solve the numericals. Another formula which tells the relationship between the cell potential and this equilibrium constant K is cell potential is equal to 0.0592 upon N log to the base 10 K. This is only true when the temperature is 25 degrees Celsius. We have seen a similar type of formula for cell potential in my previous video for Nernst equation. It was for the cell potential, while this is for the standard cell potential. K is an equilibrium constant, R is a gas constant, and T is the temperature. Let's see how to use these formulas to solve the numericals. This MCQ is 7th MCQ from Maharashtra State Board 12th Standard Science textbook. Here the reaction is given which has Ni plus Cu plus 2 ions giving Ni plus 2 ions plus Cu. We can see that the concentration is 1 molar here, which is a standard concentration. The standard cell potential is also given and we need to determine delta G, that is Gibbs free energy. E cell is equal to 0.57 volts, and as we can see that charge on Cu is plus 2, therefore the electrons or the charge is 2 here, so we can take N is equal to 2. We need to find delta G, and therefore the relationship between the delta G naught and E naught cell will be using. Delta G naught is equal to minus NF E naught cell. Now let's just plug the values in the equation. N is equal to 2 mole of electrons, F is 96500 coulomb per mole of electrons, and E naught cell is 0.57 volts. We can see that moles and moles can get cancelled out, and after doing the multiplication we get this answer. Remember the relation coulombs is equal to joule per volt, so we will plug this coulombs into joule per volt so that volts and volts will get cancelled out and we get answer in joules. But all the options are in kilojoules, so let's convert this joules into kilojoules. We know that 1 kilojoule is equal to 1000 joules, I have taken 1000 joules in the denominator so that joules and joules will get cancelled out, and we get our final answer as minus 110 kilojoules, which is option B. We can see there are two options, but this negative sign really matters, which tells spontaneity of the reaction. Remember that whenever cell potential is positive and Gibbs free energy is negative, that time the reaction is going to be spontaneous. Let's solve fourth question from question number 4 from the same textbook. Here equilibrium constant for the reaction is given and we need to determine the standard cell potential. The answer is given. Let's see how to get this answer. Given terms are equilibrium constant K equal to 1.2 into 10 raised to 6, and the reaction is also given. We can see that the charge is plus 2 here, and while on the left hand side there are 2 Cu plus ions. Therefore, N will be equal to 2, which is equal to charge or the electrons. We will be using an equation which gives the relationship between the standard cell potential and equilibrium constant K, which is E naught cell equal to 0.0592 upon N log to the base 10 K. We can use this directly because we are finding a standard cell potential. So we have plugged the values of R, T, and we have directly got this as 0.0592 upon N. Now let's see the solution. I have plugged the value of N and K in the equation. After doing the maths and the calculations, we get a final answer as 0.36 volt, which is the exact and correct answer. So in the same way, we can find the cell potential if the K is given, we can find K if the cell potential is given, and we can use various such thermodynamics relationship to find various thermodynamic quantities and tell about the spontaneity of the reaction. Alright, so this was all about this part of electrochemistry. For the further concepts, you can watch my other videos and my previous ones. If you have not understood any concept from this video or my previous video, please let me know in the comment section. Also, if you are expecting any video on any particular topic or any particular numerical, you can write that in the comment section or you can mail me. I'll be very happy to make a video for you because your feedback really matters. Till then, thank you and stay safe.